This is problem number 5 from section 3.4. It says solve the inequality, and the inequality they give us is a quadratic inequality. So the first thing I'm going to do is I'm going to replace the inequality sign with an equal sign. So let's replace that inequality sign with an equal sign, and that would be 4x squared plus 8x plus 5 equals 0. And then I'm going to, because of the leading coefficient of 4, I'm probably going to just go straight to the quadratic equation. So let's pull out the quadratic formula, and let's start to solve using the quadratic formula. So I'm going to start by saying x equals negative 8, because 8 is b, plus and minus root, this is 8 squared, minus 4 times a, which is 4, times c, which is 5. And that's all over 2 times a, which is 4. So now I'm going to get x equals negative 8 plus and minus root, this will be 64 minus 4 times 4 is 16 times 5, which is 80. So I get minus 80. And that's all over 8. So then I go to solve this, I get x equals negative 8 plus and minus root negative 16 over 8. I go and continue solving here. You'll see I'm going to get a complex number. So I end up with negative 8 plus and minus root of negative 16. Well, that is 4i, right? Because the negative 1 is I and root of 16 is 4. That's all over 8. So I end up with negative 8 over 8 plus and minus 4i over 8. So I get x equals negative 1 plus I over 2, or negative 1 minus I over 2. So these are the roots that I got for this problem here. But both roots are complex. Okay, so both roots are complex. Now here's what I want you to understand, because both roots are complex. If we draw this function or graph this function, okay, this function is an upward facing parabola, and it's got two complex roots. If I pull back in the situation where I have two complex roots, that occurs when the quadratic does not touch the x-axis, right? Doesn't touch the x-axis. So if I draw this quadratic looks something like this, where it doesn't touch the x-axis. But our inequality sign says greater than 0. Well, our quadratic is above the x-axis, right? So our quadratic is always greater than 0. Because this quadratic is always greater than 0, that means we have all real solutions, because no matter what, the quadratic is above 0 and it says greater than 0. Now what happens if it says less than 0? If this says less than 0, we would have no solutions for real solutions. So we have two complex roots, right? And the two complex roots tell us that the graph looks like this. And because we know the graph looks like this, and our inequality sign is greater than 0, we know that quadratic has all real solutions because it's always above 0. Hope that makes sense.